Algebra 2, lesson 3-1. Number 1, solve the equation x squared minus 2 equals 7 using the indicated method. So first it wants us to solve by graphing. It's easier to graph it in the calculator, so let's do that. Go to graphs, x squared minus 7, and it looks like that. X is supposed to be minus 2. And then the other one is 7. The other line is 7. So we need to find these 2 points. Mean u, 6, 4, negative 3, 7. Mean u, 6, 4. And that's 3, 7. So we got x equals negative 3 and x equals 7. Solve by factoring. Okay, so we've got x squared, so this is b, solve by factoring. X squared minus 2 equals 7. So let's subtract 7 from both sides. I didn't do that wrong. That is negative 3 and 3. So I got a 7 here, and that should be a 3. Subtract 7 from both sides, and you got x squared minus 9 equals 0. Okay, what are the factors? X times x gives you x squared, so we got x squared, x times x gives you, now we've got negative 9 with nothing in the middle, so that must be a plus 3 and a minus 3. Okay, good. So x times x is x squared, x times negative 3 is negative 3x, 3 times x is positive 3x, those will cancel out. 3 times negative 3 is negative 9. Excellent. Now we set each of those equal to 0. And that gives us x equals negative 3 and x equals positive 3. That's the same thing we got over here. C, it says solve by taking square roots. So we got x squared minus 2 equals 7. Let's add 2 to both sides, and it gives us x squared equals 9. And we're going to take the square root of both sides. And that's going to give us x equals plus or minus 3. In other words, x equals 3 and x equals negative 3. Notice we got the same answer by graphing as we did by factoring, as we did by taking square roots. Okay? You get the same answer whichever direction you choose. Number 2, solve the equation 2x squared plus 3 equals 5 using the indicated method. Well, let's solve it first by graphing. 2x squared plus 3. Clear out my calculator, go to graphs, and we got 2x squared plus 3, and then the other line is 5. Again, we find the points of intersection, mean u, 6, 4, mean u, 6, 4, and we got x equals negative 1 and x equals 1. So x equals 1, x equals -1. Solve by factoring. We have 2x squared plus 3 equals 5. So this is B here. Subtract 5 from both sides, and you got 2x squared plus, oops, that's going to be -2. -2 equals 0. Divide both sides by 2. And that's going to give us x squared minus 1 equals 0. Factor it. We got x plus 1 times x minus 1 equals 0. X plus 1 equals 0. X minus 1 equals 0. Add one, or subtract 1 from both sides, and you got x equals -1. Add 1 to both sides, you got x equals 1. Same answer we got there as we got here. Solve by taking the square roots. So we've got 2x squared plus 3 equals 5. All right, let's subtract 3 from both sides, and you got 2x squared equals 2. Divide both sides by 2, and you got x squared equals 1. Take the square root of both sides, and you got x equals plus or minus 1. So you got x equals 1 and x equals -1. Doesn't matter which way you do it. All three ways give you the same exact answer. Let's try another one. Number 3. It says solve the quadratic equation by taking square roots. Okay, first I'm going to divide both sides by 4. And I get x squared equals 6. Next, I take the square root of both sides. And I get x equals plus or minus the square root of 6. I guess you could put that in a calculator and you'd get 2 point something or another, but that would be an approximation and not the exact answer. This is the exact answer. Well, let's try number 4. Start off by subtracting 15 from both sides, and you've got negative x squared over 5 equals -15. Multiply both sides by -5, and you get x squared equals positive 75. Let's take the square root of both sides, and we get x equals plus or minus the square root of 75. Now I'm looking at the square root of 75, and I notice that there is a perfect square in there. So we got the square root of 70, let's see, the square root of 75 equals the square root of 25 times 3. Okay, and the square root of 25 is 5, so you have 5 times the square root of 3. So your answer is x equals plus or minus 5 times the square root of 3. Think about it, think about it. If you've got a fraction 2/4, okay, you're supposed to rewrite it as 1/2. Okay, it's the same concept here. Same concept here. All right. Let's try number 5. We have 2 times 5 minus 5x squared equals 5. First, I'm going to distribute the 2. That's going to give me 10 minus 10x squared equals 5. Next, I'm going to subtract 10 from both sides, and I got negative 10x squared equals -5. I'm going to divide both sides by negative 10, and that gives me x squared equals 1/2. Now I'm going to take the square root of both sides, and I get x equals plus or minus the square root of 1/2. Well, they don't like fractions in there, okay? So the square root of 1/2 That equals the square root of 1 over the square root of 2. So now we're going to multiply that by the square root of 2 over the square root of 2. The square root of 1 times the square root of 2 is just the square root of 2. The square root of 2 times the square root of 2 is the square root of 4. And that's going to end up being the square root of 2 over 2. So your answer is going to be x equals plus or minus the square root of 2 over 2. And that's your final answer. Number 6. Well, let's add 8 to both sides. We got 3x squared equals 20. Divide both sides by 3. We got x squared equals 20 over 3. Take the square root of both sides. And we have x equals the square root of 20 over the square root of 3. Skip a step there, okay? Because we're going to have to do something about that. So that's going to be plus or minus. And it's going to be the square root of 3 over the square root of 3. That's going to give you the plus or minus the square root of 60 over the square root of 9. Well, the square root of 9 we know is 3. So it's going to equal plus or minus the square root of 60 over 3. Well, hold a second. Is there a perfect square in there? I think there is. The square root of 60, I think is the square root of 4 times 15, which is 2 times the square root of 15. So let's go over here and make this 2 times the square root of 15 over 3. Good job, folks. Let's try number 7. Write and solve an equation to answer the question. Give the exact answer, and if it's irrational, give a decimal approximation to the nearest tenth of a second. A squirrel in a tree drops an acorn. How long does it take the acorn to fall 20 feet? Well, if you remember back from the lesson, it gave you d of t equals 16t squared. Okay? Now it's saying that d of t equals 20. So to find out what t is, we're going to have 16t squared equals 20. Divide both sides by 16, and we got t squared equals 5/4. 20 over 16. 4 goes in that 5 times, 4 goes into that 4 times, so it reduces to 5/4. Well, let's take the square root of both sides, and we get t equals the square root of 5 over the square root of 4. And that's plus or minus. Well, we know the square root of 4 is 2, so we got plus or minus the square root of 5 over 2. All right. Just looking at this, do you know how long that is? Does that make sense to you? Probably not. So let's go to our calculator, and we got the square root of 5 over 2, and we got 1.118. So we're going to say that's t is approximately 1.1 seconds. All right, so when that squirrel drops that acorn, you got 1.1 seconds to get out the way if it's 20 feet up. A person washing the windows of an office building drops a squeegee from a height of 60 feet. How long does it take the squeegee to pass by another window washer working at a height of 40 feet? Well, let's see here. Again, if you go back into your lesson notes, h of t equals h sub 0 minus 16t squared. Okay? And if h of t is 20, the initial height, it said, was 60 feet. So we're going to have 60, that's h sub 0 is 60, minus 16t squared equals 20. Now I'm going to subtract 60 from both sides, and I got negative 40. Negative 16t squared equals negative 40. Let's divide both sides by negative 16. And what do we got? We got negative 40 over negative 16. 4 goes in that 10 times, and it goes in that 4. Ooh, we could have done better than that. How about 8? 8 is a little bit better. 8 goes in that 5 times, 8 goes in that twice. So we got 5 halves here. Okay. Well, maybe we should leave it at 10 fourths. Let's leave it at 10 fourths. 10 fourths. And the reason why, you'll see why we're doing that here, because we're going to take the square root, right? So let's leave this at 10 fourths. We're going to take the square root of both sides. And that's going to give us t equals plus or minus the square root of 10 over the square root of 4. See why I changed it back? Which is plus or minus the square root of 10 over 2. Well, that almost looks like twice what the other did. Let's see. So we've got the square root of 10 over 2, and that's 1.58 seconds. So I'm going to say t is approximately, that's why I got that squirrely thing there, 1.6 seconds. Doing good, folks. Let's keep it up. Oh, number 9. Geometry. Determine the lengths of the sides of the rectangle using the given area. Give answers to both exactly and approximately to the nearest tenth. So the area of a rectangle is 45 centimeters squared. Well, remember, area of a rectangle is length times width, right? All right, so what do we got here? We got the width is x, the length is 3x, so we're going to have 3x times x, and that's going to equal 45. Okay, so this is 3x squared equals 45. Divide both sides by 3, and we got x squared equals 15. Take the square root of both sides, and we got x equals plus or minus the square root of 15. Well, I don't know, well, I kind of, anyway, let's find out what the square root of 15 is. The square root of 15 is 3.9. So we're going to say x is approximately 3.9, was it centimeters? 3.9 centimeters. So we're going to say this is 3.9 centimeters, and this is going to be times that by 3. So we go times 3. And we got 11.6 centimeters. And this is going to be 11.6 centimeters. Good deal? Let's try number 10. The area of a rectangle is 54. Well, we already did some of that before, right? We've got 3x times x equals 54. So 3x squared equals 54. Divide both sides by 3, and we got x squared equals 18. Take the square root of both sides, and that gives us x equals plus or minus. Now 18, that sounds kind of funny. 18. Well, I'm thinking that's the square root of 9 times 2, which gives me 3 times the square root of 2. Oh, 3 times the square root of 2. Okay. So x is approximately, let's go to our calculator, 3 times the square root of 2, and that's 4.24. So we're going to say just 4.2. And that's 4.2 centimeters. And okay, so if we go back here, this is now 4.2 centimeters, and this, we'll have to multiply that by 3. Times 3, that's 12.7 centimeters. So that's going to be 12.7 centimeters. Doing well, folks. We're moving right along. Oh, yes. There we go. Find the square of the imaginary number. Now it's a party. We're gonna work with imaginary numbers. Okay? You're used to playing with your imaginary friend. Now we're gonna play with imaginary numbers. It says find the square. So we're going to square 3i. That's going to give us 9i squared. Hold on a second. I squared is -1, so that's going to be times -1 or -9. If we got our inspire here, we're going to say, we're going to open this up and open parentheses 3, and down here where the pi button is next to the h, we get our I, and then close parentheses squared, -9. Cool. What about here? What about there? Well, let's square it. What do we get? We get I squared, and then we get, well, the square root of 5 squared is just 5. So that's I squared times 5. And I squared is -1 times 5. That gives us -5. Let's try that in our calculator. Open parentheses. I times, I think it was the square root of 5. And we'll square that. -5. Cool. I got 2 in a row. What about this one? This one looks like fun. So let's square it. Let's square it. What do we got? Okay. Well, we got to square everything inside, right? So we got negative, and this is going to be the square root of 2 squared over 2 squared. And looky here, I got this I here. That's going to be I squared. Right? Okay. Well, that's going to give us -2 over 4, right? Times, well, -1. Well, that's negative squared, so that's going to become just 2/4, which is 1/2 times -1, which is -1/2. There's an awful lot going on in there. Let's try that in our calculator. Open parentheses, and we've got -I times, and that was control divide the square root of 2 over 2, and then we're going to square that. -1/2. menu, 2, 2, negative 1/2. All right. I was worried there for a second. Number 14. Number 14. Determine whether the quadratic equation has real solutions or imaginary solutions. Well, how do we know when it's got an imaginary solution? Well, if it has the I, it is an imaginary solution. So let's do this. I guess the easiest way would be 15x squared equals 10. I added 10 to both sides. Divide by 15. And let's see, 5 goes in that 2, goes in that 3. Take the square root of both sides. And I got x equals plus or minus square root of 2 over the square root of 3 times the square root of 3 over the square root of 3. That's supposed to be a 3. All right. So x equals plus or minus the square root of 6 over the square root of 9. So x equals plus or minus the square root of 6 over 3. The solutions are real. All right. We can find that on the number line. Okay, we can also find it on the graph. Over here, let's subtract 12 from both sides, and we got 1/2 x squared equals negative 8. Multiply by 2, and you got x squared equals negative 16. Take the square root of both sides. Uh-oh, we can't take the net. Oh, you can with imaginary numbers. Remember, we have x equals plus or minus, wait for it. The square root, that's going to be the square root of negative 1 times the square root of 16. All right, the square root of negative 1 is I. The square root of 16 is 4. So we're going to have plus or minus 4i. The solutions are imaginary. And that's because we got the I there. Now what about this one here? Number 16. Well, let's get rid of the parentheses. We got 10x squared minus 15 equals 4x squared minus 40. Move that over there, that gives us 6x squared. Move that over there, and that gives us negative 25. Divide both sides by 6, and we got negative 25 over 6. We're going to take the square root of both sides. Okay. And that's going to x equals, now wait for it. We got the negative. That's going to be, well, the square root of negative 1 times the square root of 25 over the square root of 6. And we got plus or minus out here. We'll forget about that. Well, the square root of negative 1 is I. The square root of 25 is 5 over the square root of 6. Please don't forget the plus or minus. Well, now we're going to multiply the top and the bottom by the square root of 6. And that's going to give us x equals plus or minus 5i times 6. So we got 5i times the square root of 6 over the square root of 36. And the square root of 36 is 6. So we've got 5i times the square root of 6 over 6. And there's your answer. And the solutions are imaginary. Cool beans. What else we got here? Oh yes, this is one of the good ones. We got bunches. Solve the quadratic equation by taking square roots. Allow for imaginary solutions. Alright, this looks a lot harder than it is. Let's see. We got x squared equals negative 81. So let's start off by taking the square root of both sides. And that's going to give us x equals plus or minus the square root of, we got negative 1 times 81. Well, the square root of negative 1 is I, and the square root of 81 is 9, so we're going to have 9I. Okay. What about over here? Let's subtract 64 from both sides. We got x squared equals negative 64. Take the square root of both sides, and we got x equals plus or minus. Well, this is going to be the square root of negative 1 times 64. The square root of 64 is 8. The square root of negative 1 is I. So we got plus or minus 8I. Let's go over here to number 19. Let's add 4 to both sides. And we got 5x squared equals negative 4. Divide both sides by 5. We got x squared equals negative, and that's 4 over 5. Let's take the square root of both sides. And we have x equals, well, that's going to be the square root of, that's going to be plus or minus the square root of negative 1 times 4 over the square root of 5. So x equals plus or minus 2I over the square root of 5 times, well, the square root of 5 over the square root of 5. Remember, we can't have that square root in the denominator, so that gives us plus or minus 2I times the square root of 5 divided by the square root of 5 times the square root of 5 is the square root of 25, which is 5. We have done it. Let's subtract 10 from both sides. We have 7x squared equals negative 10. Divide both sides by 7. We got 7x squared equals negative, that's 10 over 7. Let's take the square root of both sides. And we have x equals plus or minus, we'll have the square root of negative 1 times 10 over the square root of 7. Okay, I can take the I out, but I can't do anything with the 10, so I'm going to go ahead and do this conjugation and get rid of that radical in the bottom. It's going to be plus or minus. I'm going to take the I out, the negative 1 out, and then I got 10 times 7, that's going to give me the square root of 70 over the square root of 49. Well, the square root of 49 is 7, so let's take it one more step. Plus or minus I times the square root of 70 over 7. And there's your answer. Good job. Good job. Determine the length of the sides of each square using the given information. Okay, there's a lot of information there. It says squares, right? Well, what's the area of a square? The area of a square is s squared, right? Because it's length times width, which would be s times s, or s squared. Okay. The area of the larger square is 42 centimeters more than the area of the smaller square. So look at here, we got 2x, so we've got 2x squared. The area of the larger square is 42 centimeters more than the area of the smaller square. So we got 42, or let's just write it like this. X squared plus 42. So let's distribute that square in there. We got 4x squared equals x squared plus 42. Well, let's subtract x squared from both sides, and you got 3x squared equals 42. Divide both sides by 3, and you got x squared equals 14. So let's take the square root of both sides, and we've got x equals plus or minus the square root of 14. Now think about it. Can you have a negative dimension? You cannot. So x really equals the square root of 14, which is approximately, let's get our calculator. The square root of 14 is 3.74, so we're just going to say 3.7. We're just going to the 10th. Is approximately 3.7. So this is 3.7, and let's see, multiply it times 2, and we get 7.5. So this is 7.5. All right, folks, you did wonderful. Thank you very much. See you in class tomorrow.